Hello again. Welcome back to the channel. Today for a new video, which is involving this instrument, the BOONTON 92B RF millivoltmeter. I had an issue with the instrument. Unfortunately, it was due to me working on the instrument to try to solve a problem, a small issue the instrument has. Eventually, I made an error because I broke a pin on the mechanical chopper. Unfortunately, this could mean the end of this instrument's life. I tried to see what can be done, and unfortunately, these are old instruments. The only thing the most easy thing I can think of is to find another instrument and for parts only, and try see if the mechanical chopper inside is still working and swap the parts. So I'm gonna post a picture of it. There we go. As you have seen, the mechanical chopper is a piece, an entire piece, and one of the 3 pins broke off, and those are the 3 pins where you plug in the driving signal from the chopper drive board through a plug, a 3-pin plug. Unfortunately, I put it on and off a few times, not just this time, but also in the past. And one of the 3 pins, the center one, the one on the center tap, was loose. It was coming up and down, so it was just a matter of time. And eventually, that happened yesterday morning when I was trying to. When I was reinstalling all the parts, because I opened up the instrument to swap some caps and try to solve the issue of this instrument, of the issue that I have on my instrument. Anyway, so with one of the pins of the chopper won't work anymore, obviously. So try and look for other instruments for parts only. They're not very popular here in Europe, so try to look for it in USA. These instruments were made in USA, New Jersey, I think. There are some units for sale, even broken units for parts, but yeah, you have to hang around a bit probably, and before you can find a good opportunity, because I don't want to pay 150 euros for a broken instrument. The cheapest one I found at this time was $45. Still, I paid 70 euros for this unit, and it was coming with a probe and a 50 ohm termination. Just to give you an idea, I have seen just the probe, just this probe for sale at more than 100, 150. Or even yesterday I saw it for a crazy price, like crazy, like several hundreds of dollars. No way. Anyway. Also, you have to keep in mind that the probe must match the instrument. So usually they do it in the factory and they put the serial number of the instrument on the probe. So this probe is not from this instrument, but then I have recalibrated the instrument with this probe, so that was okay. Anyway, yeah, there are some other accessories like the T for measurements up on higher frequency, higher than 600 megs. Anyway, so basically I wouldn't give up to the idea of this instrument not working anymore. So I would either sell it for parts myself as well, or keep it to use the internal parts in case in the future. But was really a shame. So what I did is I try and understand how this piece is made. So as you can see, you got some pins, insulated ones, then there's one for shielding. Okay, so looking at this piece, now you already see the solution, because I decided to shoot the video afterwards. And I'm shooting the video in order to help anyone else that might have this problem, saying that maybe the instrument life is not yet at the end. So on this side, and now I don't want to make other errors because this is very delicate, but basically this is a cap, as you can imagine. Okay, I will post all the pictures of it when it was. Okay, so basically what I did was, this is the part number. There are different types, okay? Mine is 113, I've seen 127, 126, or even others. Anyway, so I started to scrub off this black coating, which to me looks like a coating. It's not like you see, it's like a coating. It's not like a thermal piece of shrinking tube, you know. It looks really like a coating. I started to scrub off the coating on the side of this cap, and eventually, because if you see here, if you look carefully, you see this kind of dent on the tube. So I thought maybe this is a cap. So I scrapped off the coating, and I was even more sure that that was a cap. So then I started using my soldering iron with a large tip, the largest I have. Put it on 500 degrees, the maximum, and just let it rest on top of the cap. And with my surprise, I saw the cap opening. So I open all the cap and I see the 3 wires. Now the 3rd wire here, it was broken. Okay, so now I scrapped off the jacket, ready to be reinstalled. But basically, yeah, the pin, and this is the pin that is loose. Let me see, let me show you. There you go, see, it comes off very easily. So on the inner part, this pin has a hole. Let me reposition the camera to show you. Okay, I don't have a microscope. I'm using just the phone and a lens, so forgive me. Anyway, as you can see, there's a hole in this pin, and you can still see the broken wire inside. Unfortunately, I can't get it off, but fortunately there's enough space for the wire to get in. So I'll just don't bother and put the wire in and leave the rest inside as well. So this is the pin. On the other side is just I mean the hole is only on one side. On the other side is just plain, okay? And I'll show you now how is fixed on the cap. Okay, this is the cap inside, and as you can see, there's an insulator in the holes. Those three wires are insulated from the shielding. This wire is the one on the center tap, and these are the extremes of the coil. So here, I don't know if you can see it, but the pins, those two pins are well, at least for now, fixed on the insulator, whereas this one here lost, like, you know, it's a bit loose, you know, lost a little bit of the material that was keeping it in place. So now the pin just goes in and out too easily. So I'll have to find a way to attach, to make it solid. Here you go. I'm gonna lose this pin. I have to find a good way to attach. I think I'm gonna use some good glue, because I'm just concerned that I don't want any conductivity between the pin and the shielding. So if I put some glue around, I want to make sure that the glue will be a good insulator. Actually, it could be now, but who knows with time, you know, with years. Maybe it will absorb some humidity from the air over the years and will start conduct. Unfortunately, that's why I'm not really a fan of putting glue. I will think about it, see if I can find a different solution. Well, a solution could be to replace those pins, or lift those two pins and just solder another piece of wire passing through and getting out, and then change the plug in order to make it a little bit different system, not to stress mechanically this part again, you know. So, well, that's it for now, I guess. I'm gonna think about a solution, but yeah, maybe then I will post another video. But for now, my goal was to share my experience with this mechanical chopper, okay, in order to help someone else with the same problem. And I didn't say that before, but basically the mechanical chopper is doing what is represented here in this schematic. So the pin 5, 6, 7 are those three pins up here and represent the coil where we got a current going through back and forth about 94 hertz, and the magnetic field is probably acting inside like an electromagnet, and there's this kind of single pole double throw pins 3, 2 and 4, and pin 1 is the shielding. So the contact is going left and right hinge on number 3, and is touching 3, 2 and 4 like this. Okay, but at very high speed, not like me, about 94 times per second, and the frequency you can adjust it from inside the instrument. So what it's doing is basically he's receiving the DC voltage rectified by the probe, rectified by the diodes in the probe, and this DC voltage is then converted by this mechanical chopper into a square signal, okay, with this frequency 94 hertz, and then the AC, this AC square signal is treated afterwards. Well, that's how it works. It's obviously is a mechanical piece of kit, so it's delicate, is prone to wear over the years, but it was working before I had this problem. And when you switch on the instrument, you can hear actually inside this buzzy noise doing zzz, which is the switching commutation at 94 hertz. Pretty interesting. Anyway, then on the later versions of this BOONTON, I guess starting from the C, I think already on the C version, there's the A, the B, the BD, which has some digital part, the C, the E, you know, many different versions. Lately they used they replaced this mechanical chopper with an electronic circuit with no mechanical parts moving. Anyway, that's it. That's all for now. I hope that was of any help to someone else. Well, thank you for watching.